Hi, my name is Feo. I'm a designer at Arduino. In this video, I will show you how to connect one of our boards to the upcoming Arduino IoT Cloud. The platform is still in private beta, but you can follow the link below, fill in a form, and request access. We are slowly granting access to more and more people every week, so bear with us if we don't reply right away. At the moment of this recording, only the Maker 1000 and Maker 1010 are supported, but we are working really hard to bring more connected boards to the Arduino IoT Cloud. I would say, let's get started. For this guide, I put together a very basic setup. It's a couple of breadboard and I'm using two just to reduce the clutter in the view. There's an Arduino Maker 1000, which is one of the wireless boards currently supported by the Arduino IoT Cloud. I have a push button connected to digital pin 5, an LED connected to digital pin 2, which is also PWM capable, and I have a potentiometer connected to analog input 1. I have written a very simple sketch which allows me to test that these components all work together. So essentially in the loop, when I read the digital input for pin 2, if it's high, I'm going to turn the LED on. And to make sure that the potentiometer is working, I'm using digital pin 2 with a PWM output, so I can control the brightness of the LED just by rotating the potentiometer. So you can see the LED gets dimmer and brighter. When I release, it's off, push, it's on, and I can control it. Now that I'm sure that all my parts work, let's see how we can connect this to the Arduino IoT Cloud. I'm now assuming that you have access to the Arduino IoT Cloud beta, and if you don't, please just write to us in the forums and ask for access. We're gonna quickly get back to you and let you help us make this thing better. In order to get started, there's a couple of concepts that we need to make clear. So, because it's a secure layer connection between the Arduino board and the cloud, the IoT Cloud, we need to make sure that the certificates needed for the board to authenticate on our network are properly installed in the security chip. Right, we're not going to go too deep into it. Let's just say that we want to provision our board with the certificates. And the way we go about this, well, the easiest way is to basically just go to the Arduino Cloud and run the getting started process to get us going. So the whole thing, a bit of nomenclature here. A thing is basically an IoT Cloud object which allows your board to communicate with our cloud and exchange data. The way we want to go about this, we want to create a new thing and we want to give it a name. So I'm going to call it Arduino IoT Cloud Demo. I'm going to select a board. I don't have a board because I'm assuming that the board has been just purchased or has never been configured to run on the IoT Cloud network. So let's just go through this step. Currently supported are Maker 1000 and Maker Wi-Fi 1010, which has this new ESP32 module on it. But we are working very hard every week to bring more boards into it, and there's a couple ones which are going to be quite interesting the moment they come out. So at the moment I have a Maker 1000 and there I go. I'm going to provision a Maker 1000 to be connected to the Arduino IoT Cloud. It's very simple. You can read through it. I already have the Arduino Create plugin, so I don't need to do this. Let's do start. The system is recognizing the board. I'm gonna give it a name, which is Maker 1000 underscore IoT. I have done this in the past, that's why my browser remembers it. Next, we are going to configure the crypto chip on your board. As I said, this will allow the Maker 1000 to securely communicate with the Arduino IoT Cloud, and you will be able to use the network monitor, which is another component. It's an extension of the serial monitor, which allows you to do IoT Cloud virtual serial. We're going to configure it. Now what's happening is that the Arduino Create environment is uploading a configuration script onto your Maker 1000. The board and the cloud are going to communicate and exchange some information in order to generate a cryptography certificate that will be installed on the microchip onto your Arduino Maker board. So this has worked out, everything worked, so we can go back to the cloud. Now we're going back to the screen we were before, so let's say that we want Arduino IoT Cloud demo. We want to create our thing, and we can directly select the board to attach there, or we can configure a new one, assuming that you have another Maker 1000 or a Maker Wi-Fi 1010. We're going to create our thing, and of course we need to enter some Wi-Fi network because this thing will connect to your Wi-Fi. My current Wi-Fi is this, your may be different. I'm sure yours is different. And now I have this very basic empty template. What we want to do, we want to create some objects for our board and sketch to communicate with. And we call these objects properties. So they're properties of our Arduino IoT Cloud thing. I'm going to create one to handle the data which comes from the potentiometer, so I'm going to call it potentiometer value, and I'm going to assume that this one is an integer, right? So it's a number between 0 and guess what? Let's make it between 0 and 100. We know that the potentiometer with 10-bit resolution can give us a value between 0 and 1023, but we're going to remap it on a scale between 0 and 100. We're going to make this a read and write property, so we can read it from the cloud dashboard, but we can also write it back. The value will be updated when the change is at least 1. I'm going to create it. Now I need something for the push button, right? And I want to call this, let's say, switch state. So when I push the button, it gets switched on, and when I push it again, it gets switched off. We're creating a toggle, essentially. This is going to be on-off, read and write, when the value changes, and let's create this one. Now the last one, we want the LED to be controlled from our dashboard. You'll see what I mean in a second. So we're gonna call this LED state, and it's going to be on off, and it's going to be read and write, and there we have it. We have 3 properties to interact with the 3 physical objects which we have on our breadboard. Let's see what this looks like. As you can see, you have 3 boxes which say no data yet received. This means that the sketch running on the board has never connected to this Arduino IoT Cloud thing, which is not a bad thing. We haven't generated any code and we haven't uploaded any code. So let's go back to edit, and we'll click on this edit code because these 3 properties are all we need to get started. Edit code is going to bring us into our code editor on Create, and it will create a sketch with the same name of your thing and add the date and a unique ID at the end. The code is all generated and it can already work, right? So we have a scaffolder for our code. We have a define, which basically stores the unique ID of our thing, which has a name, but it's identified by a unique ID. And there's some extra tabs which are useful for cloud configuration. We're still working these things out, so some of these are ideally gonna disappear, and more functionalities are gonna be added to the Arduino IoT Cloud library. So let's quickly look into this. This tab handles all the connection, disconnection, reconnection, as well as cloud status. Then we have cloud properties. These are created for us. We don't need to create these. And if you look through the code, you may easily understand what they do. Essentially, they connect the instance of the Arduino IoT Cloud library to the properties and the local variables. The local variables are here. We have variables with the same name as the properties we have created in the thing. They're called potentiometer value, switch state, and LED state. And our secret is, of course, our network connection. And now you know that my network password is my cat's name. Let's quickly run through the code generated by the platform to see what happens here. So we said there's a thing ID, which allows us to connect the sketch to the thing in the cloud. These are connected to the secret tab. We are including Arduino Cloud settings, which handles all the connection and disconnection, as we said. And we initialize the serial. We want to see some data in the serial monitor. Then we call init properties, which is here, and init properties connects the local variables to the Arduino Cloud instance. And we init the connection, which is here, and it allows us to connect to the Wi-Fi and to the cloud. And then in the loop, there's only two operations happening. We send an update to the Arduino Cloud instance, and then we check the network connection, right? These, you can write all your code in between these two. You can see that there's three methods which have been generated by the platform, and these are basically callbacks. So when we change the potentiometer value from the cloud, this function is triggered. When we change the switch from the cloud, this function is triggered. And when we change the other switch, which is connected to the LED state, this function gets called. In a moment, you're going to be able to see what I mean with this. The first thing that we need to do, well, we want to upload this code on our Maker 1000 board, which is here, and see what happens in our cloud dashboard. Let's upload. I'm going to open the monitor right away. This way, the moment that it starts connecting, I can see what's happening. The first thing is going to connect to our Wi-Fi network. Once it's connected, it's going to attempt connecting to the Arduino Cloud. As you can see, our dashboard has updated from 3 yellow boxes to 3 boxes with a widget inside. So essentially, this LED state widget is connected to this property. Potentiometer value, which is a value between 0 and 100, is connected to this property. And the switch state is, of course, connected to switch state. We've seen that there's three methods generated by the scaffolding code, and these are callbacks which are triggered every time we change something from the dashboard. This means that if I flip this, a change will be triggered and this function will be called. So what we can do in here, we can set the code to turn our LED on and off. So of course we need to, initialize the LED pin and everything. Let's define a few things. LED pin is going to be 2. Then we have potentiometer pin, which is on A1, and then we have switch pin, well, that's a button, so button pin on 5. In our setup, what we want to do, we want to set these pins as inputs and outputs. So pin mode, LED pin output, pin mode well, that's analog, we don't need it. Button pin is input. So let's see if we can trigger the LED from within the dashboard. What we want to do, we want to digital write LED pin. We want to give it the value high or low depending on the state of our button in the dashboard. So let's just say that we're gonna set it to LED state. And just for, verbosity, print LED state, serial.println LED state. This way we can see something in the serial monitor. Let's upload this code. Sometimes when you upload the code, you don't get an immediate connection. So this may happen. In case it does, just reset the board after uploading the sketch. There is some kind of a timeout in the connection between the client and the server. Now let's see. First thing, connecting to Wi-Fi. Once that connection is successful, it's going to connect to the Arduino Cloud. We had a failed connection. Let's just reset our board. The timeout is about a minute, so on reset you should be able to reconnect. Exactly. Now it's connected. This means that our dashboard is currently connected to our board and our sketch. Let's see if the code that we just implemented on LED state change reflects some changes in the terminal. Switch it, and you can see that our code worked. It's been triggered, so LED state is equal to 1. And if you see, our LED is now on. And I'm going to keep playing with this. Off, on, off, on. Very good. You can see that the connection is really fast, and I'm using a mobile hotspot, and the weather is quite bad today, so it's not really affecting the performances of my connection. Now what we want to do, we want to connect our potentiometer to this slider. So you can see that we change the value in the dashboard, but nothing happens. What we need to do, well, we can either output something in the serial monitor from this, but we already have code in place that basically maps the potentiometer to a value between 0 and 100. So what is happening here is that when I try to move it, in our loop, it keeps getting updated based on the analog input that the analog read on pin A1 is giving us. This means that if I move the potentiometer, I'm going to have the value remapped between 0 and 100 and display in the dashboard real time. And it is happening. Well, this is the second input successfully connected to the cloud. And once again, I'm going to, at the same time, rotate this and switch the LED. You can see that they play really nicely together. Okay? And then we have this other dashboard button, which is switch state. And switch state at the moment is not really doing anything because we have not connected our push button to switch state. Let's go and do that. I want to make sure that the switch on the breadboard acts as a toggle for a variable which is here, and it's called switch state. Now I could be writing all the code and just say previous state, future state, and current state, and all the other flags, but I prefer to use a library which I wrote with my friend Sebastian to handle bouncing and button state. So it is essentially a debouncing library which can be used as a button manager. You can find it on my GitHub. I'm gonna put the link in the description. And I'm going to instantiate the debouncer manager. So ft debouncer, oops, deb. And what I need to do, essentially, because my button is going to be handled by the debouncer, I do not need to use the pin mode because the library does it by itself. I just need to do add pin button pin, and I'm going to specify the state at which it is when it's resting. And you can see there's a pull down resistor 10K, which means the button is normally low. Now I can initiate the debouncer, and the only thing that I need to do in my loop, I need to run the debouncer. So I need to basically tell the library, check the state of the buttons which I'm taking care of. Let's see the run method here. Okay. Now, what happens is that every time a button which is managed by this debouncer changes state, one of these two functions is going to be called. So the library expects these functions to be defined in our sketch. We're going to add them at the very bottom. And well, I'm just going to show the pin number which has been activated and deactivated. So the pin activated function is triggered every time we push the button, and the pin deactivated is triggered every time we release the button. Because we want this button to act as a toggle, the only thing that we need to write is basically every time it gets activated, switch the value of switch state. So very simply, we're gonna write switch state is equal to not switch state, which basically reverses between true and false every time it gets activated. So let's upload the sketch again, and this is the last bit of our example. And we're back in business. So let's open our dashboard. Let's twist the potentiometer. This works. There is some wiggling. The potentiometer is not really firmly set in there, and the mapping is playing some tricks, but it's fine. Let's switch the LED from the dashboard, and now let's see what happens when we push this button. You see, the dashboard switch state has switched. And if we go and see what's happening here, the library is triggering the pin activated, the debouncer library is triggering the pin activated function, and this is switching this variable, which is a boolean, that it is. And when this boolean switches between 0 and 1, so between false and true, it gets sent to the dashboard. Well, there we have it. We have a fully functional dashboard, IoT dashboard. It's really fast, really responsive. We are able to trigger things from the cloud to the board and vice versa. And this is a very basic getting started guide, and I'm sure that it's going to originate some questions on your end, and I really look forward to answering those questions. Mind that we are making changes pretty much every week, so some things will be different the moment you try this tutorial. When big changes happen, we send emails to the email address connected to your Create account, and we invite you to read through those emails. Some of those changes are breaking, and your examples may not work anymore. So mind that when we have really important stuff, we will send you an email. We'll try not to bother you if it's not necessary. Thank you very much for having been with us, and we look forward to your questions and to your feedback.